Alright, so before I start the lesson, I don't know if this lesson really doesn't really work if students don't know already how to factor, but also at the same time I would never teach the word factoring after a lesson on how to factor. So in order to understand any of these examples, they pretty much have to understand how to factor. Alright, so now that that's out of the way. Alright, last class we talked about how we factor polynomials. So during this class we're going to be discussing more about what factoring is and getting into what it means. So I want you guys to take a minute or two, think to yourself about how we factored polynomials in the last class. What are some of the steps and how we went about factoring? And then after that, I'd like you to turn and talk to your neighbor about how we factor. Maybe discuss some of the key elements of factoring, how we did it. So go ahead and do that now. Okay, so now after that I would have each of the partners turn back, and I would pick a volunteer, and I would have the volunteer tell the class what their partner said, not saying what they said. So I have a volunteer now.
Alright, so essentially when we factor, we are splitting up the factor into like what it was used to multiply up into. So you
What's the goal? What was the goal of factoring?
The goal was to find your x-axis.
Right? Close. Our goal was to find points on our x-axis where our graph intersects, our function intersects. So that's what we're doing. That's great. Thank you. So today we're actually going to be getting into what factoring actually is. So we define factoring as the action in which a polynomial is represented as a product of simpler polynomials that cannot be further factored. So we're first going to identify the key components or key attributes of our definition, kind of pick it apart. So in our definition we see that polynomial seems to be a pretty key factor in our definition. That's what our basis is, that's what we're starting with. And then we're representing our polynomial as a product of simpler polynomials. That's also pretty important. And also this last part, they cannot be factored further. So we're going to talk about what each of these mean independently, and then we're going to talk about their relationship with each other too. So, and then we're going to eventually form our own definition. So, what's a polynomial? We've seen a polynomial before. That's something like x squared plus 3x plus 6, right? A polynomial has more than two terms, which is a binomial. So this is a trinomial, a polynomial. A polynomial is a function with many terms, right? So, and each of the terms are connected by an operation, right? So we can identify what a polynomial is. Now, we can also, based on our last class, right, we know what a product of simpler polynomials is too, or a product of polynomials, right? That's how we were factoring. So a product of polynomials would look like how we factored before, right? Our two factors, in this case we have two factors because we know the degree of our polynomial is 2. So we know we have two factors. If this was a 3, we could have 3 factors, and so on, right? So, let's go through how we factor this. We know that these are both going to be pluses because the operations in our polynomial are all positive, right? So now we need to think of two numbers that multiply together to get our coefficient here, our constant term, but also add together. I'm just going to go through a non-example. So, yeah. Multiply together to give us our constant term and add together to give us our linear term. And we see these would be 2 3s. So we could check this again. Remember how I said we could check this by multiplying it the whole way back through to get us to the thing we started with, right? So we use FOIL again. So we start with first, x squared, then outer, plus 3x, plus inner, plus 3x, plus last, 9, Remember, we're always multiplying in each of these steps of the FOIL. If we combine these two, we get 6x, and we see we ended up with what we started with, right? Good. We also saw much simpler polynomials that need to be factored. So what if we had 2x squared plus 4? Now, like I said before, generally a polynomial, we call a polynomial something with many terms, but also we can identify a polynomial as something with, I guess, only 2 terms. So we could factor this as, we could just pull out a 2. Since each of these terms both have a factor of 2, you can pull a 2 out of both. So 2 times x squared plus 2 is essentially the same as, if we want to redistribute this 2 to each of these terms, we get back what we started with. Right? All right. So now, I'm going to go through a non-example, something that is not correct, that we know for certain is not correct. Oh, I guess, yeah, let's go back to that example, or an example. Square plus 5x plus 6. Okay, so remember, this is not correct, right? So I'm purposefully doing this incorrectly. Our first step looks correct so far, right? We take our 2 pieces from our quadratic term. So let's check this now, right? I made an incorrect step somewhere, right? So now we can check it. We see x squared. We did FOIL again. X squared plus 6x plus that should be 1x. Getting ahead of myself. Plus 6x plus 6. But we see here that these linear terms, if we rewrite this again, this doesn't equal what we started with, does it? So we did something wrong in here. What did we do wrong?
It should be a -1. So then it would be 6x minus 1x, which is 5x.
Not quite. It's very close. So let's try that. So which one did you say?
Minus 1.
Minus 1? So let's try that. Right? Let's do FOIL again. So we get x squared minus x plus 6x minus 6. So now we have x squared plus 5x minus 6. That's not quite the same as what we started with, is it? So you're on the right track. However, we want to be careful because we know that both of the signs in our original polynomial are pluses, so we know right away that both of these signs in the middle should also be pluses. Our mistake was rather choosing our factors. It should have been 3 and 2. Very good. All right. So now let's see another example. So this one's going to be a little trickier. This one is x cubed minus 2x squared plus x minus 2. So this one's a little trickier, but we're going to factor it by grouping. So we're not going to factor it the same way we did before. We're not going to do this with 3 different factors because that could be a little tricky, all right? So what we're going to do is we're going to look at these first, these terms. We're going to separate them into pairs, right? So we have in this group here, in group 1, label them group 1, group 2. In group 1, we have x cubed minus 2x squared, all right? So we can factor an x squared out of each of these terms, right? So x squared times x minus 2, right? So we can't do anything else to this part. Now, in the second group, in group 2, we have x minus 2. And we can't do anything to that. That's fully factored. So we can just bring that down here. Now, to finish this off, we know that this, in between this plus sign and this parenthesis, I give us a little bit more space, there's an imaginary, or an invisible 1 right there. Right? We don't always write that, but that's there. So by grouping, we're taking the first term, the outer term in each of these, the 1 and the x squared. Now we're combining them. X squared plus 1 yeah, I think it's like this, times x minus 2. And we can check this. See, I don't even really know if I did this right. But we can check it anyway, right? Using what we did before. So that's the same as do FOIL x cubed minus 2x squared plus x minus 2. That looks awfully similar to what we started with, doesn't it? In fact, it's the same thing. All right. Are there any questions on that example? Nope. Good. I think I may have gotten a little ahead of myself. So let's backtrack a little bit. Now since we've seen a few examples and a non-example, I maybe should have done this before starting the examples and non-examples. Let's try to form our own definition or a more student-friendly definition that doesn't look as intimidating. So what's our definition of factoring going to be? So we can say, based off of the things that we've seen, factoring is taking a polynomial. We know what a polynomial is, right? We identified that. And rewriting it, that's what we're doing. Rewriting it as the product of two or more why two or more? I made that very specific there. Why two or more?
Because if it is only 2, it's a binomial. But if it's more, then it's a polynomial.
Careful. Not quite. You're on the right track. Remember I said we have two factors if the degree of the function is 2, and we have more if the degree is higher than 2. Like we saw in that last example, the degree was 3, but if we would have solved that function, we would have had where x equals something 3 times. But we only saw 2 factors. This is a little misleading. You're close. 2 or more. 2 or more. I don't know if I want to say smaller, but I will. Two or more smaller polynomials, which we can't factor anymore. So it's a little different from our original definition. So you can pick and choose what you want to include in your notebook about factoring. Either definition should be fine, as long as you understand one of them. So now I'm going to give you a situation. You're going to determine whether it's an example or non-example. based off of what we've seen so far. So we'll have x squared minus 11x plus 18. And this equal sign with the question mark over it means, does it equal that or not? So, think to yourself, is it an example or not an example? Okay. Is it an example or not an example?
No.
Why not?
It should be negative 18 and negative 1. Oh, wait.
Yes.
Negative
Well,
negative 9, negative 2.
yeah. Negative 9, negative 2. Correct. So no. And we corrected it, so it should be x minus 9, x minus 2. We FOIL that out again, we can check it. X squared minus 2x minus 9x plus 18. And that, combine these, you'll get 11x, negative 11x, and that's what we started with. Very good. How about another? Example or non-example? This one's a little trickier. Yes, example. Why?
Because when you multiply it out, you get x squared, and you'll get negative 9. The x minus 3 and the x plus 3 will cancel each other out. So it won't be a single x and x 1. And then it'll be
That's right.
minus 9.
Very good. The linear terms, the negative 3x and the positive 3x cancel out, and we end up with x squared minus 9. Check. Example. All right. How about one more together, and then I'm going to give us a few to work on independently. All right. So how about example or non-example?
No.
Yes. No, because we did not factor this correctly or completely. The only thing we did was we took a 3 out. We still have this mess right here. Right? We didn't finish this problem. So, no. This is not an example. Like we said in our definition, we have to fully factor our polynomial in order for us to technically be factoring it correctly. Or we can't take any, we can't split them into smaller polynomials again, but we can. All right, so now I'm going to give you 3 more to do on your own. So, Sorry, I'm taking a little bit, trying to make it interesting. So sloppy too. All right, so I want you to work on these problems. And this, if you don't get done with this, this will be part of your homework assignment. After this, we're going to be working on factoring again, more review of how we factor, and there's some problems in there to ask you to correct mistakes like we did in class today. And yeah, so finish this in the time we have remaining, and if we don't get it done, please do it for homework.